Okay, so if we look here for part two, we were considering whether traveling to Mexico and to Canada were independent events. In class, we said there is no association, they're independent events. When we compare their segmented bar graphs, these are at the same height here. Whether or not you know that I went to Canada is not going to help you figure out if I also traveled to Mexico. Given this, we're going to use this property to fill out our contingency table. So, if I say that of the 45 people that traveled to Canada, 18 of them traveled to Mexico, it should be the same proportion for people who did not travel to Canada. So I'm going to set this up as 18 to 45 as x is to 20. I'm going to solve for my x. So I'm going to get 8 here. Now that I have that, I can fill in the rest of my table. This is going to be 26. This will be 12. This is going to be 27. And then 39 and 65. Okay, I'd like you guys to use your contingency table to fill out the chart below. Please pause the video and complete the chart. Okay, so at this point, you should have done the chart yourself and you're checking against my answers. You want to take a look at this chart. There's some interesting patterns happening here. What you should notice, remember in this case, we were looking at things that were independent events, okay? We can compare the chart to the chart from the front page. And what you should see here is there's one interesting relationship. These are equivalent. So this only happens when you're talking about things that are independent. It was not true for things that had an association. So the probability of A times the probability of B is equal to the probability of A and B. This only happens when we're independent, and this would be something that you could use as a nice check if you were doing some type of multiple choice type of problem. Okay? Now, if we want to talk about the true definition of independent events, we're going to look here, and we're going to go to the other parts of our table that we haven't looked at yet. So we're looking at the probability of C happening. So if you notice, that is the same as the probability of C given M. Similarly, if you look at the probability of M happening, that's the same as the probability of M given that C happened. Now this is only going to occur when things are actually independent. So the probability of A given B is equal to the probability of A happening, because the fact that B happened had no effect on A. It didn't matter. So that is our true definition of independent events. At this point, you should be flipping to part 3, and there's a video that goes with part 3 on the next part of our website.